All right, so let's pick up where we left off. We just got done adding and subtracting rational numbers, fractions. So now let's jump into multiplying and dividing rational numbers. So the rule for multiplying is actually very, very simple compared to adding and subtracting. So in this case, if you're multiplying two fractions, all you do is multiply the tops and multiply the bottoms. That's it. Nothing else. Now, obviously, you want to reduce in there when possible, and we're going to see some little tricks that you can do when doing these problems as well. All right, so let's look at the first one. We got 3/4 times 9/5. So if we multiply straight across, 3 times 9 is 27. 4 times 5 is 20. And done. Now, should you change it to a mixed number? The general rule would be yes. Anytime you can change it from an improper fraction to a mixed number as your final answer, you should. So how many times does 20 go into 27? It only goes in once. And there's 7 left over. So we should get 1 and 7/20. Okay, so now we're done. All right. So it doesn't seem like there's anything drastic here, right? Well, let's take a look at the next one. If we multiply straight across, we have 5 times 4, which is 20, and then 12 times 15, which is 180. All right, so now this one, we can kind of see that there's going to be some canceling that we can do. Now, anytime you have a numerator and denominator that ends in a 0 like this, you can just cross them right out. Because essentially what you're doing is you're dividing 10 out of both of those. So this reduces to 2 over 18. And now, if you wanted to divide the 2 out, that's going to get you down to 1/9. So that's one way you can tackle it. Now, here's what I would recommend, though. If you look a little more carefully at the original problem, even though there's nothing we can do vertically with 5/12 and there's nothing vertically we can do with 4/15, we can look diagonally for common numbers, common factors. So in this case, 4 and 12 can be reduced because 4 goes into 12 evenly. So it's a little bit of a dividing trick. It's sort of like using that property from before to reduce down, but we're just reducing diagonally instead. So 4 goes into itself once, and 4 goes into 12 3 times. So you're not dealing with such large numbers, not that they're that large, but you're not going to have to deal with large numbers when you cross cancel like that. Same thing with 5 and 15. 5 goes into itself once, and it goes into 15 3 times. So now when you multiply across, we got 1 times 1, which is 1, and 3 times 3, which is 9. So you can see we get the same answer either way. Now, some people have a little bit of an issue with this cross-canceling business, but again, it's optional. You don't have to do that, but I would advocate that you do it because it's going to make life easier on the front end when you start to multiply stuff down. This is a little bit more messy. So let's take a look at a mixed number problem. Now, just like before, we changed them to improper fractions first. It's the same thing here. We have to change them to improper fractions. There are other options up here that we could have done, and some of you might know other options, but if you're not sure or if you're just plain rusty, I would always go with the improper fraction route. But for multiplying and dividing, you have to do improper fractions. There's no way around it. So, okay, so let's change them to improper fractions first. Now, we got to be a little bit careful with this negative sign because some people want to try to incorporate that into the process of changing it, and you don't want to do that. So just pretend it's not even there and just say, okay, what's 4 and 7/8 as a mixed or improper fraction? So 4 times 8 is 32, plus 7 is 39. So 39 over 8. And now you can just put the negative sign in front of it. That's the safest way to do it. All right, and now we got 3 times 3 is 9, plus 2 is 11. So we got 11 over 3. All right. So now we should look to see if we can cross cancel. It's going to make life easier. You don't want these bigger numbers to deal with. So, but if we look diagonally, 3 and 39 can be reduced. So 3 goes into both of them. 3 goes into 39 13 times. 3 goes into 3 once. So now the numbers are a little bit smaller. Still not great, but they're smaller. So now 13 times 11 is 143. 8 times 1 is 8. And are we forgetting anything? Don't forget the negative, because one of these fractions is negative, so that's going to dominate and make the whole answer negative. So we got negative 143 over 8, but we got to change it back to a mixed number. So how many times does 8 go into 143? Well, it goes into 14 once, and there's 6 left over. 8 goes into 63 7 times, with how much left over? 7. Now, like I said, until you get the hang of it, it doesn't hurt to do it on the side just to make sure you're doing it right. So you got 8 goes into 143. Let's double check. It goes in once, and so 8, if we subtract, we get a 6. 8 goes into 63 7 times, 56, running out of room. Subtract that and we get 7. So there's that 7 for the 7/8. So 17 and 7/8, and don't forget the negative. All right. So let's jump over to division. Now division is going to be very similar to multiplication because we have a rule that we can use to change it to multiplication. So anytime we're dividing something, we can rewrite it with the division symbol, but then what happens is the second fraction gets flipped. Now this is the definition, but the practice you want to follow is actually right here. This is really the rule that you want to look at. So we got one fraction divided by another fraction. The first fraction doesn't get touched. Just like with subtraction from before, we don't do anything with that first number. So the first fraction doesn't get touched, but the second one gets flip-flopped. So some people like to call this the switch and flip. So you switch the division to multiplication, and then you flip the second fraction around. And there's all kinds of other names for it too, which you probably know. So once it's multiplication, though, you can follow all those same rules. You can cross cancel or not, but in the end, you want to multiply straight across on the top and bottom. So you got to be really careful and deliberate and making sure your steps are separated. So let's try a couple. Negative 9/16 divided by negative 3/8. So if we first change it to multiplication, your first fraction stays the same. Your second fraction gets flipped. And now we can see if we can do some cross canceling, which we can. So 9 and 3, we can divide the 3 out. 8 and 16, we can divide 8 out of that. And so now 3 times 1 is 3, 2 times 1 is 2. And is your answer going to be positive or negative? It better be positive. So positive 3/2. And then your last step is to change it to a mixed number. So this will be 1.5. All right. Let's try this one. This one's got a little bit more substance to it, but we got parentheses, so we know we got to do those things first. So we got to subtract and we got to add before we do that division. So let's see what we get. Now, because we're adding and subtracting, we have to have the same denominator. So that's the first step. Get those denominators the same. And because 4 goes into 8 evenly, 8 should be our denominator. So let's change that to an 8. And we got the same situation going on in the second set of parentheses. So now, what's our new numerators going to be? So we changed the 4 to an 8, so we had to multiply it by 2. So if we multiply 1 times 2, we get a 2. Over here, 4 times 2 is 8, so 3 times 2 would give us a 6. All right. So now we can do our subtraction and addition. 5 minus 2 is 3, and 1 plus 6 is 7. All right, so that takes care of the adding and subtracting. So now we got to divide, but we got to apply our rule. Switch and flip. Switch and flip. Now this one's pretty nice because the 8's are going to cancel each other out completely. And when we multiply straight across, we get 3/7. All right, not too bad, I hope. All right, I don't want to get this video too long, so we're already at 11 minutes. So let's stop here. And then we got a little bit left that looks at the decimal side of fractions. So we talked about that before, but now we're going to see exactly what is the criteria for a decimal to be considered a rational number. So we'll see you in the next video.